Hello, this is John from caveofprogramming.com, and in this tutorial we're going to look at using iterators and at the iterable interface. So let's say you've got a list. I'll make this a linked list, and this could store any kind of object, but I'll store strings here, and I'll call that animals because I'll put animal names into it, and I'll set that equal to a new linked list of string. And now the normal way to iterate through this list would be to use a for each loop, and a for each loop uses the for keyword as we've seen before, but it's called for each because you're doing something for each item in the list, and in lots of other languages it actually uses the keyword for each, but in Java it's for. So I say I declare a variable of the type of thing that's in the list, and I put a colon and then the name of the list, like this. And now I can do sysout animal, and of course I need to add some things to my list to actually make this work. So let's add some items into my list. I'll say animals.add fox, and let's duplicate this line. 1, 2, 3. That's enough. And I'll add in cat, dog, and rabbit. So if I run this, no surprises here, it just outputs my list. Now, before Java 5, there wasn't this kind of for each syntax, and the way to do it was using an iterator, and iterators still have their uses now, which we'll take a look at. So let's put a comment here. This is modern iteration, which is like post Java 5, or I should say Java 5 and later. Now, before Java 5, the way you do it was this. You take your list and you say iterator, and that returns an object of type iterator with a capital I. So I say iterator, I could call this it equals my list name, animals in this case, dot iterator, and I'll add the import there with Control-Shift-O. Now the reason I can do this on a linked list is because lists implement, and a lot of collections in general, implement the iterable interface. So let's go to the internet here and search for Java iterable. And the iterable interface just specifies that a class should have one method called iterator, which returns an object of the type iterator. And if we take a look at that, an iterator has a method hasNext, which tells you if there is a next item in the list. It has next, which returns the next item, and it also has remove, which removes an item. So the idea behind an iterator is that it can point at each item in the list in turn. And if I say, for example, string animal equals it.next, and I run that, actually let's first, what did I do wrong here? Cannot convert from object to string. Oh yeah, the iterator is actually a template type, so I need to specify the type of thing that it's going to point at here, and since I've got strings in my list, it's going to be an iterator of strings. And let's output this animal here. So I'll output the text that I return, and I'll just put a sysout here to create a blank line. Now that will get the first value in my list, or at least it should if I get rid of my errors. Oh yeah, I've got two strings called animal here, so let's just call this value, and finally I think I can run it. So my output here is this is outputting the first item in my list, and when you call next, it makes the iterator move on to the next item and return it at the same time. So before you call next on your iterator, it's as if this iterator is pointing just before the first item in your list, and when you call next, it's now looking at the first item well, the next item in your list, which to start with will be the first item, and then it returns it. And the way you normally use this is you normally use it in a loop so that you can point your iterator at each item in turn and use it to retrieve each item. So to do that, I say while it.hasNext, and hasNext tells me if there is another item in the list that the iterator can point at. So while your iterator has a next item to point at, move it to point at that next item and return the item. And this will display my entire list. Here we go. Now the advantage of this is that you can use it to remove items if you want to. So let's say, for example, if value.equals cat, then I can say, okay, I want to remove this item, so I can say it.remove. So remember, when I call it.next, it's going to move it to point at the next item at the same time that it returns that item. And I can then say, okay, if the value that you just returned and that you're therefore pointing at is equal to some particular item, then remove that item. So if I run that now, okay, we see cat is still output because I'm outputting it before I remove it here. But then when we iterate through the list again, the second time, it's gone from my list. So this is coming from my for each loop down here, and now I've removed cat. And I can't do that with a normal for each loop. For example, if I say in a normal for each loop, animals.remove, and I try to remove an item, for example using an index like 2, if I do that I get a concurrent modification exception, meaning I'm trying to modify the list concurrently with iterating through it, and that's not allowed. So I can't do that. If you want to remove items from a list while you're iterating through it, you have to use a iterator. And a couple more things to mention here. One thing is that for each actually uses iterators behind the scenes. So if you implement iterable, which we'll get onto doing probably in the next tutorial, in your own class, your own collection class, you can then use a for each loop to iterate through it. So even though there's no mention of iterator here in this modern syntax, it's in fact doing this behind the scenes. So this is still very much an integral part of Java. And the other thing to mention is that if you want to add items to a list while iterating through it, then instead of using iterator, use list iterator, and that will return you a list iterator. And list iterator, in fact, does allow you to add items to your list. So if I search for list iterator here, Java, then we can see that list iterator has a add item as well as remove, and it also has a previous method, which is the opposite to next. Previous will rewind the iterator to point at the item before the one that it's currently pointing at, and that will allow you to add items in before the current item, for example. Okay, so that's it for this tutorial. And by the way, the reason that I used linked list here was because although you can add items or remove items from the middle of an array list, it's not efficient to do so. And if you're adding or removing items from anywhere other than the end of a list, you should use linked list rather than array list. Okay, so that's it for this time, and next time we will most likely go on to look at implementing iterable in your own classes. So join me again then, and you can find this code on caveofprogramming.com, where you can also find courses on Android, web programming and Java Swing, among other things. And until next time, happy coding.